explain about amplitude modulations. Amplitude modulations. What is amplitude modulations? Time domain representations of amplitude modulations and frequency domain representations of amplitude modulation. First, what is an amplitude modulations? Amplitude modulation is one of the analog modulation technique. Analog modulation technique. Amplitude modulation is one of the analog modulation technique. So here amplitude of the carrier is varied. Amplitude of the carrier is varied. Amplitude of the carrier is varied in accordance with message signal. Okay, in accordance with instantaneous value of message signal. Okay, a signal. Now here only amplitude is varying, other two parameters, that is frequency and phase, remains constant. Frequency and phase remains constant. Phase remains constant. Then transmission bandwidth of amplitude modulations is 2 FM, where FM is message frequency. And what are the definitions of amplitude modulation? Amplitude modulation is one of the analog modulation technique where amplitude of the carrier is varied in accordance with instantaneous value of message signal. So this is all basics idea about amplitude modulations. Just I am going to glance here. What is an amplitude modulation? Amplitude modulation is one of the analog modulation techniques, and here amplitude of the carrier is varied in accordance with the instantaneous value of message signal. Here frequency and phase remains constant, and the transmission bandwidth of the amplitude modulation is 2 FM. Now we will discuss about time waveforms. Okay, waveforms of amplitude modulations. Then we will go with time domain representations and frequency domain representations. So consider that a message signal. Consider a message signal m of t. Consider this is a t and this is a message signal m of t is a low frequency signal. How we are going to conclude this? It is a low frequency signal. It is based on the time t, one complete cycle. So this is an a t, and f is equal to 1 divided by t. As t is increases, f is decreases, inversely proportional. Then consider in a carrier signal a c of t. For modulations we need two things, one is message signal and carrier signal, correct? So in the last class I already explained in detail about the modulation techniques, what is modulations, why it is required. Now a carrier is a high frequency signal and which carries the message signal from one place to another place. High frequency signal like this. High frequency signal. So on what basis we are telling that this is a high frequency signal? Based on the t, complete one cycle. Consider one complete cycle. Then f is equal to 1 divided by t. As t is less, frequency is high. That's why carrier frequency is higher than the message frequency here. Then come to the point here. I am going to write a modulated signal. Actually modulated signal is represented as s of t r, correct? Fine. Now it is very simple. As I said that AM, okay, this is an AM wave. What is that amplitude modulations? Amplitude of the carrier is varied in accordance with instantaneous value of message signal. How it varies? Look at here. So whenever the message signal amplitude is high, we are going to get a high amplitude here, like this here. Then whenever it is a low, you are going to get very low amplitude, like this. So it is not possible to write properly. Yeah. Yes, it is like this. It is very simple. Whenever message amplitude is high, at that time we are going to get a V maximum. Okay, this is called as a V maximum, and whenever message amplitude is low, and you will get V minimum. So this is called as V minimum, and so this is called as V maximum. Okay. So in this way, amplitude of the carrier is varied in accordance with instantaneous value of message signal. So this is a modulated signal. So this it is T. This is all about introductions parts of an AM. Okay, what is an AM? Waveforms of AM. Now I will go with time domain representations of AM. Time domain representations of AM. Time domain representations. See, time domain representations of AM, it is very important concept. Yeah. So message signal is represented as m of t, and it is given by m of t is equal to am into cos of 2 pi fm t. So here this is the way of representations of message signal. Message signal is represented as m of t. M of t is equal to am into cos of 2 pi fm of t. So call this equation 1. So it is very simple. What is that? Am, amplitude of the message signal, and fm is the frequency of the message signal. Okay, each signal has its own amplitude and frequency. So this is a message signal has am amplitude and fm frequency. Okay, similarly, so this is message signal. Similarly, consider any carrier signal. Carrier signal is represented as an C of t, so it is equal to AC into cos of 2 pi fct. Okay, call this equation 2. So what is that? AC, amplitude of the carrier signal, and fc means frequency of the carrier signal. Correct? Okay. Now call this equation 2. So here we know that standard equations of AM wave. Okay, standard equations of AM wave, which is equal to S of t. Okay, S of t, which is equal to AC into AC into 1 plus Ka into m of t, Ka into m of t into cos of 2 pi fct into cos of 2 pi fct. Now it is very simple. So S of t, just write as it is. Just we need to simplify this. S of t, then AC. Okay, AC keep as it is. 1 plus Ka keep as it is. What is that? M of t. M of t from equation 1. From equation 1, m of t is equal to am into am into cos of 2 pi fm t. Okay, am into cos of 2 pi fm t whole bracket into cos of 2 pi fct. Now just I am going to expand this. Okay, open this bracket. Okay. Now S of t equal to is equal to AC. Okay, just I am going to multiply here. AC into cos 2 pi fct, AC into cos 2 pi fct plus AC into Ka into am into cos of 2 pi fmt into cos of 2 pi fct, cos of 2 pi fct. Just I am going to take different pen. Yeah, so it is very simple. Just I open this bracket here because AC into cos 2 pi fct is common. So AC into cos 2 pi fct, that is the first term. Then AC into Ka am cos 2 pi fmt into cos 2 pi fct. Now so it is very simple. S of t. Okay. Now it is in the form of before that I am going to write one more step. S of t is equal to AC into cos of 2 pi fct plus AC into I am going to take a mu. So what is mu? Mu is equal to Ka into am is called mu. So then it becomes mu AC. Ka into Ka into Ka into am. Okay, Ka into am is called as mu. What is that mu here? Modulation index. Okay, fine. Okay, Ka into am is mu. Okay, mu AC keep as it is, then remaining thing write as it is, cos 2 pi fmt into cos 2 pi fct. Cos 2 pi fct. Now look at here, it is in the form of cos a into cos b. Okay, if first term keep as it is, yeah, so s of t is equal to first term keep as it is, so AC into cos of 2 pi fct first term keep as it is, then apply here cos a into cos b formula. So what is cos a into cos b formula? Says that it is 1 by 2, correct? 1 by 2 cos of a minus b. So 1 by 2 into cos of a minus b. Now observe very carefully here which is a and which is b. So you need to consider this is a because carrier frequency, you need to consider carrier frequency as a because it is a high frequency signal. So when you perform cos of a minus b, okay, you should get positive values, correct? So high frequency minus low frequency, you will get positive. So if you consider this is an a, fm is an a, then you will get negative value. So that's why consider 2 pi fct is an a, cos of a minus b, correct? Cos of a minus b. So cos of 2 pi, 1 minute, cos of, okay, okay, cos of 2 pi, okay, cos of 2 pi fct. Okay, this is a minus b, so 2 pi fmt. So cos 1 by 2 cos of a minus b plus 1 by 2 cos of a plus b. This mu AC by 2 is common. Okay, 1 by 2 cos of a plus b, 2 pi fct plus 2 pi fmt. Just further simplify this. Okay, now s of t is equal to AC into cos of 2 pi fct plus mu AC by 2, correct? Okay, mu AC by 2, mu AC by 2 into cos of, this equations can be rearranged, cos of 2 pi fc minus fm into t plus mu AC by 2 into cos of 2 pi fc plus fm into t, because it is very simple. Cos 2 pi is common, take outside, and t is also common. So cos 2 pi t is common, fc plus fm, correct? Yeah. Now observe very carefully, this is the time domain representations. Okay, time domain representations of AM wave. It consisting of mainly 3 frequency component. One is carrier itself, then it is fc minus fm is lower sideband, and fc plus fm is upper sideband, correct? So upper sideband, lower sideband, and carrier frequency. So this is the time domain representations of AM wave. Then we need to calculate a frequency domain representations. Frequency domain. So for calculating a frequency domain, we need to apply Fourier transformer. How you are going to convert time domain into frequency domain? By applying a Fourier transformer. By applying a FT, Fourier transformer. Then apply a Fourier transformer. Then okay, then it becomes S of t becomes S of f. I'm going to use, yeah. So S of t becomes S of f. Okay, it is equal to, so what is the Fourier transformer of AC into cos 2 pi fmt? Okay, cos 2 pi fct, sorry. Okay, what is the Fourier transformer of cos 2 pi fct is 1 by 2. Okay, 1 by 2. Okay, del of f minus fc plus del of f plus fc. Okay, you need to remember this. what is the Fourier transform of cos 2 pi fct? It is 1 by 2 del of f minus fc plus del of f plus fc. So this AC keep as it is. AC keep as it is. Then similarly, then calculate the Fourier transform of this mu AC by 2 keep as it is. Mu AC by 2 keep as it is. What is the Fourier transform of, again here, cos 2 pi fct. Okay, so this one is 1 by 2, then it becomes mu AC by 2, 4, it becomes a 4, then del of f minus f minus fc is this total term we need to consider, fc minus fm, though it becomes minus fc plus fm, minus fc plus fm, minus fc plus fm plus, okay, plus del of f plus fc, plus fc means you need to keep as it is here. Consider this entire thing as in a fc, so fc minus fm, fc minus fm. Okay, this is the Fourier transform of the second term. Similarly, calculate the Fourier transform of the third one, AC by, same here, 1 by 2, it becomes a 1 by 4 into del of f minus fc. Fc means this entire term, correct? F minus minus fc means minus fc minus fm. So here minus fc minus fm plus del of f plus fc, f plus fc. Fc means just write as it is, fc plus fm, fc plus fm. What about this? So this is the frequency domain representation. Okay, frequency domain representations of AM wave. Then here we need to sketch, okay, sketch the spectrum. Okay, it is very simple. You need to draw, sketch the spectrum. Then I am going to share f minus fc and plus fc. So plus fc somewhere here, correct, and minus fc somewhere here. Then see, minus fc plus fm, minus fc I am going to add for fm, that you will get here minus fc plus fm at this point. Okay, then fc minus fm, so this is fc minus fm. Okay, fc minus fm, you are going to subtract, no? Yeah, that's why fc minus fm, fc minus fm, then minus fc minus fm, so this is minus fc minus fm, we are getting here minus fc minus fm. Then what is the last one? Fc plus fm, so I am going to add here, so here fc plus fm here, right? Okay, so what is the amplitude here? Mu AC by 4. Okay, its amplitude is mu AC by 4. I am going to write like this, spectrum. So its amplitude is mu AC by 4. Okay, mu AC by 4, mu AC by 4. Okay, so what about this? So this is frequency spectrum S of f, and this is an f. So this is time domain and frequency domain representations of AM wave. Just I am going to glance once again what are the concepts we have discussed here. Yeah, so we have discussed what is AM. AM is an amplitude, one of the analog modulation technique. Here amplitude of the carrier is varied in accordance with instantaneous value of message signal, and frequency and phase remains constant, and its transmission bandwidth is 2 FM. So consider this a message signal and this is a carrier signal. Amplitude of the carrier is varied in accordance with instantaneous value of message signal. How it is varies? It is very simple. Whenever the message amplitude is high, we are going to get a V max, and whenever message amplitude is low, and we are going to get V minimum. Then I am going to derive time domain representations and frequency domain representation. Okay, just for time domain representation, we need to consider message signal. M of t is represented as AM into cos 2 pi FMT, and C of t is represented AC into cos 2 pi FCT. And this is very important thing, we need to remember this. This is the standard equations of an AM wave as modulated signal. S of t is equal to AC into 1 plus Ka M of t into cos 2 pi FCT. Then substitute the value of M of t. M of t is nothing but Km into cos 2 pi FMT. Then open this bracket and apply. It is in the form of cos A into cos B formula. So it is in the form of cos A into cos B formula. Cos A into cos B formula is equal to 1 by 2 cos of A minus B and cos of A plus B. So then you will get the S of t. It is in a time domain representations of AM wave, and it consisting of mainly three carriers. One is carrier itself, three bands. One is carrier itself and upper sideband and lower sideband. Then next, frequency domain representations of an AM wave. How you convert time domain into frequency domain? By applying a Fourier transformer. So AC keep as it is. What is the Fourier transformer of cos 2 pi f c t? That is 1 by 2 del of f minus fc plus del of f plus fc. Similarly, here mu AC keep as it is. Fourier transformer of this, again it is 1 by 2, it becomes a 1 by 4. So into cos of, into del of f minus fc. F minus fc means it becomes minus fc minus fm. Okay, 1 minute. Oh, it is minus, no? Minus fc plus fm. Okay, fine. Then plus del of f plus fc, f plus fc. Okay, fc minus fm, fc minus fm. Similarly, apply same thing here. It is mu ac by 4 and del of f, f minus fc means minus fc minus fm, minus fc minus fm, and plus del of f plus fc, f plus fc means write as it is, fc plus fm, correct. So and you need to sketch the spectrum here. You need to sketch the spectrums here. See here, plus fc and minus fc, just mention a plus fc and minus fc here. Then what is the next? Minus fc plus fm. Okay, for this minus fc I will going to add some fm here, hence minus fc minus fc plus fm come here. Then plus fc minus fm. So in the plus fc I am going to subtract minus fm here, that's why you are going to get here fc minus fm. Then minus fc minus fm, I will get come this point, fc plus fm means for fc you are going to add an fm, fc plus fm. So this is the spectrum of amplitude modulation in frequency domain. Thank you. And if you like my videos, do subscribe.